First, we make sure we have the appropriate number of connections from our switch to support the traffic we expect in the cluster. In our case, we have network interface cards of two 100 gigabits per second ports from each appliance, which in turn means that we are expecting 600 gigabits per second of traffic. So you can see we have 6 ports in our switch which can carry 600 gigabits per second. Now, let's connect our Maestro deployment devices. First are the sync ports of the orchestrators. So port 32 of orchestrator 1 to port 32 of orchestrator 2. Next, we will connect the gateways to the orchestrators. Those are the downlinks, used to pass the traffic through the orchestrators to the appliances and back. Remember, odd ports to orchestrator 1, so we will connect port 1 of the first appliance to the first downlink port, number 17 of orchestrator 1. Then, port 1 of the second appliance to port 18 of orchestrator 1. We are left with the second ports on each appliance, so we will connect the even ports of each appliance to orchestrator 2. So from port 2 of the first appliance to port 17 of the second orchestrator, and from port 2 of the second appliance to port 18 of the second orchestrator. I previously mentioned the option of using DAC cables and would like to show it to you before we move on. This is your direct attach copper cable. As you can see, it is thick and its connector is a little cumbersome, so will require more space for cable arrangement due to its reduced flexibility. Let us put one in. This is how it would look. DAC cables are reliable and cheaper than fiber, but harder to manipulate and limited in the distances they can be used for. However, each deployment is different and affected by different environmental and practical variables, so it's totally up to you. We will return to the fiber connection just so you have a better visual of the rack and its connections. We have all the downlinks in place. Let's move on to connect the uplinks. These ports connect your Maestro setup to your infrastructure, your switches. We need to make sure that we allow enough capacity to carry the expected traffic from the 3 appliances we are planning for this security group. So, we will connect 3 fiber cables from the uplink ports 2, 3, and 4 of each of the orchestrators to the switch. So we will have 3 100 gigabits per second links from each orchestrator going to the switch. This leaves us with the management connections of the orchestrators only. Later, we will show the security group creation and the establishment of the link aggregation for management, MAG0. So for now, we will connect ports 1 on both orchestrators to the management switch. This is the place to note that if you intend on having more than one security group in your Maestro deployment, you can choose to split your management port to 4 separate ports using a fiber splitter. This totally depends on you and how you want to manage your security groups. We successfully completed the installation of a Maestro security group. To summarize the process, after putting all appliances in place, we started with the sync port. We connected the orchestrator sync ports, number 32, to each other to give the deployment full redundancy. Then, we connected the downlink connections from the MHO to the appliances, the odd ports to orchestrator 1, which meant ports number 1 on the appliances to 17 and 18 of orchestrator 1, and the even ports of the appliances, ports number 2, to ports 17 and 18 of orchestrator 2. We then connected our uplinks, which are the connections going out from the MHO to your switch, ports 2, 3, and 4 of each MHO to the switch, and ended with connecting the management port of each orchestrator, port number 1, to the switch. We had 6 uplinks connected, 100 gigabits per second each from both orchestrators. But we have 2 appliances. That's because we are yet to add another appliance. So let's go ahead and install our 3rd member in our security group.